Hi, welcome to screencast session on week 4 breadth first search. To implement the breadth first search, we are using that existing implementation of the queue. You can find this implementation in the week 3. The same data structure we want to use it for the BFS for adding of the vertices and removing of the vertices. That is first come first serve basis. So let's implement it. This BFS function is taking two parameters, that is adjacency list of the directed graph and starting vertex where you want to start that traversal. So now we started the initial setup, the visited dictionary we are making initially all of them are false, that is for each vertex available inside your adjacency list of keys, and that key we want to create in the widget of this particular each vertex. Initially all of them are false so that none of them are widgeted. So once it is done, we are creating the instance of the queue. The queuers object of the queue is created, that's simple queue alphabet. We started from the starting vertex where you want to start the traversal. So widgeted of the start vertex, initially we make it is true. So once it is made it as a true, we are simply adding into the NQ. So NQ is existing operation. So that starting vertex has been added. So once it is done, we want to do that iteration. So what the iteration is, until my queue will become empty. So that is queue is empty. So this is empty is a function which is already available. Until my queue will become empty, we want to get it. So inside this queue, we want to get the first vertex and its adjacent, second vertex and its adjacent. So how to get it that, the vertex from the queue is simply DQ operation. So the current vertex you are getting from a removal from the queue, that is DQ operation. So whatever I got it, so in that adjacents of the current vertex we want to get it. So that adjacents of current vertex, if they are not visited, we will visit. So for adjacent vertex in adjacency list of the current vertex only. So whatever current vertex removed from the DQ, so if that is not visited, that adjacent one is not visited, then we want to make it that visited status of the adjacent is true. So once it is made as true, that visited vertex is having again set of adjacents to it. So how can I process it? Simply I am adding that adjacents to again to the queue. So that is adjacent vertex of the current vertex. So that is simply added into the queue, and this is continuous repeating the 41 line number until my queue will become empty. So once all of them are done, so final status of widgeted, you are getting like, initially all of them are false, now we are getting all of them are true. So let's do that. Cool. So now the main function, this main function I'm creating a particular adjacency list. Possibly it's a dictionary. 0th vertex, it's having two adjacents of 1 and 2. First vertex, it's having two adjacents of, let's take 3 and 4. And second vertex, it's having two adjacents of 4 and 3. And maybe third vertex is having only one adjacent of 4. Fourth vertex is having no adjacents. Now we are calling the function implemented, that BFS, using adjacency list. What is your adjacency list? A predefined. So already you define just above that, 50 file number, that is 54. Where do you want to start it from? The traversal, that is from the 0th vertex. So hopefully we have done everything. Let's run this. So you see that initially all of this widgeted matrices or widgeted dictionary is going to be false. Now the widgeted status, all of them are true, so that everyone is widgeted using this input, and starting vertex we started as 0th vertex. So thank you very much. Have a nice day.